Once again, good morning to you all. So let me start the session. So I would like to give some introduction on process first. So because today we are going to discuss on system boot and init process. So this is going to be a separate title in unit 1 mark. So this is going to be very important title, system boot and init process. This is going to be a completely theory, completely a theory content you will have in this particular topic, system boot and init process. And then so this is going to be one of the important topic in unit 1, and this particular topic which relates to a process basically. So system boot we are using process, and for init also we are going to use process, so which is completely which is deals with a process. Okay. So first I would like to give some introductions on process, and then I will give some introductions on system boot and init process. Finally, we will discuss on the presentations for that particular system boot and init process. Okay, so we'll have some slides. So with those slides, we could discuss and the same thing, system boot and init process. So the first thing is, so here we are going to use what process. So everything here, whatever we are going to do, everything which is going to be in process, and then this process basically we could divide into some two major parts. The two major parts of processes are, and the first one which is about system level processes, and second one which is about user level process. So you have some two major processes levels. The first level is system level processes. We used to call it as in system level processes. It is not a single process which is going to be in collection of processes. That's why we are referring here as processes. Okay. So you must know the difference between a process and processes. So process in the sense each and every individual process whatever that we used to have. So those single process we used to call it as an individual process, we used to call it as a process. Where collection of process we used to call it as in processes. So for managing system wide functions in your operating system, we used to have some various system level processes. This used to run throughout the entire lifetime of your system. We used to call those processes as system level processes. And then user level processes in the sense, user whenever he is going to create a new file, whenever he is going to do some actions in your system, automatically a new process will be created. Suppose he is going to click using some he is going to mouse, and then using keyboard, suppose he is going to type something, and using his mouse pointer he is going to select some icon in the desktop. For whatever the action a particular user he is going to do, for each and every action he is going to perform, a new process will be created. So those processes we used to call it as an user level processes. So we have some two major levels of processes. uh, the first one which is about system level processes, and second one which is about user level processes. So keep it in mind. And then the next important thing is about process zero. This process zero which is very important, and the other name for process zero is swapper. SWAPPER. And then you have one more process, process one which is going to be an init process. So these two process 0 and process 1, which is going to be a very important one. So starting from your booting up of your system until shutting down your system, these two processes will present. So which used to present throughout the lifetime of the entire operating system. So we have some two major two important processes, the process 0 and process 1. Where process 0 we used to call it as in swapper processes, SWAPPER, swapper. Okay. The reason for calling it as a swapper is it used to swap the process. Okay. So actually it is a process, but the work of this particular process 0 is it used to swap the process. Swapping means moving the process. So it used to take the process and it used to move the process to a particular area. So we used to call this process as swapper process. So basically we have some two memory regions. The first one which is going to be primary memory. So whatever the RAM that we have in your system or in your devices, mobile devices, those RAM we used to call it as in primary memory. And then you have secondary memory. You have some additional memory spaces for storing your files and processing your files. Those additional memory we used to call it as in what the secondary memory. So that's going to be in another memory region. The work of swapper here is what, to move the process between the secondary memory and primary memory to the secondary memory. So actually some two sets of action that we have some two actions over here, and that is swapping as swapping in and swapping out. So the swapping in means taking a particular process and from your secondary memory, suppose you are trying to move it into primary memory. So actually moving in. So the primary memory where we could execute the process. So from the secondary memory, suppose you're going to move a particular process into the primary memory, we used to call that particular action as swap in. SWAPIN, swap in. At the same time, suppose we are going to take some process from the primary memory and you're going to throw out to the secondary memory because of some reasons. Okay, because reasons like we don't have some enough memory spaces in primary memory, or else suppose that a particular process which is going to asleep in memory. So at those situations we used to throw that particular process from your primary memory to the secondary memory. We used to call them swapping out. So these are the works of what, swapper process. And then you have one more process, init process. This init process which is about initialization. The init, init, this particular word which deals with what, initialization of process. So initialization in the sense, whenever a user he is going to create a particular process, making that particular process to run or making that particular process to work, those initialization of the user processes. So make the user processes to work. So making the user process to work, so this will be handled by this init processes. So the other name for init process is process 1. So process 1, which is going to be the other name for init processes. So this process 0 and process 1 is very very important. And next we have some two important functions for process creation and then for process killing, or else to make the process to stop its work. So we have two functions for it. Actually those two functions are actually algorithm. The first one, which is about fork, fork, fork. This fork function which is going to be used by an existing process to create a new process. So the purpose of fork is to create a new process, to create a new child process. We are using this fork function, or else we used to call it as an fork algorithm. So this particular fork function will be used by an existing process. Those existing process we used to call it as a parent process. So whatever the existing process that we have in your system, those existing process we used to call it as a parent process, and those parent process will create a child process using this fork function. So parent process, an arrow mark, and then you have a fork, and then you will have an arrow mark, and finally which is going to give a product, the product which is going to be child process. Okay, so that's about fork. And then you have a function named as exit, exit. So in process states and transition we have learned it. Actually the exit system call actually in to execute the zombie state, a zombie state in the sense killing of that particular process. So after completing its work, it is going to come out of its nature. Okay, so come out of its nature. So after that it won't be in a forms of process. So to kill a particular process, we are going to use an algorithm or function named as exit, exit, exit. And then in file systems we have learned some fork blocks. Okay, in file systems we have learned some fork blocks. The fork blocks are what we have, super blocks, and then we have boot block, and then we have inode block, and then we have data block. So these are the four blocks that we have. So we have learnt about super block, and then data block, which is nothing but which used to have the data within it. So to store some data and managing those data, we're using data block. And then inode block, which refers to the files. So inode, which is going to act like an indexes for accessing files in your file system. So that's about inode block, which completely which relates to the files in your file system where and then um, various permissions or various rights about that particular file, like what are the file permissions that we have, and then what are the various things that we could do in that particular file, and when we created, when we modified, when we lost access it, and then what are the execution rights that we have, whether we could read it or whether we could write it, whether we could execute it. Okay, and then so these things, various authorizations and various rights and various permissions and various file details you will have in that inode block. Okay, and finally boot block. So the purpose of discussing these four blocks, so today we are going to discuss on what, the boot block. So that's why I'm discussing all these four blocks now. So the boot block, which is related to system boot and init process. Okay, and then the purpose of discussing about processes, swapper process, process 0 and process 1, all these things are which is related to this system boot and init process, because system, for booting purposes we are going to use a process, and for initialization purposes we are using init process. That's why I discussed about all these process 0, process 1, and various functions and swapping in and swapping out. So all these things. Okay, and then so that's it. And then in Unix system structure, we have some four important subsystems. The first topic that we discussed, Unix system structure. So the four subsystems are what we have: input output subsystems, and then we have file subsystems, and then we have process management subsystems, and then we have memory management subsystems. So these are some four important subsystems that we have. So these four important subsystems are very important, because whenever that you're going to execute a process without the support of the remaining three subsystems, so to execute a process, surely we need the support of what, process management subsystems. But whenever that you have to execute a process, surely you need the support of the remaining three subsystems, like input output, memory management, and then file subsystems. So all these things which comes into picture over here. And today we are going to discuss on what, system boot and init process. Okay, so this is very important topic, system boot and init process. And then from the title itself you will get an idea, so what we are going to do. The first one, we are going to do what, booting process. So that's about what, system boot. So system boot, which is related to booting of that particular operating system. It's very simple. So from the title itself we must have some idea on that particular topic. So system boot, which is related to booting up of your what, booting up of your operating system. Okay, and then okay, then the next one, which is about init process. Okay, excuse me, ma. So bigs are present. Okay, I will make a note of that. Ma, if there is going to be any change in attendance, finally at the end of the session, those who ever came late into the class, kindly let me know the attendance at the end of the session. So kindly tell your roll number and your name, so that I would mark the attendance for the corresponding student. Okay, so kindly let me know at the end of the session. So bigs, I will mark your attendance. So okay. um, so then, coming back, so we have what, we have a system boot and init process. So for booting process we are using what, system boot, and for initialization we are using init process. And then here you have to be very clear. So we have discussed about what, we have discussed about some four blocks. What are those four blocks? We have a boot block, we have super block, we have inode block, and then we have data block. So these are the four blocks that we have. Among those four blocks, the one of the important block is boot block. We used to call it as an block 0. We used to call that particular boot block as block 0. For booting up of your operating system, we are going to use that particular boot block. So without the help of those boot block, you won't able to start up your operating system. So keep it in mind that, or make a note of these things. So in file system you have these blocks. So first we have to use the boot block. So using the boot block only we are going to start our operating system. Okay, and after the starting up of your operating system only, the remaining process, either which is going to be an system level processes or either it's going to be an user level processes, all these processes which depends upon what this boot block, because soon after switching up of your operating system only we could manage whatever the processes that it's going to run after the starting up of your operating system. And for starting up of your operating system, surely we need the support of what boot block. And this particular boot block, which consists of a sequence, we used to call that particular sequence as a bootstrap sequence. We used to call that particular boot block as bootstrap sequence. So we are calling it as in sequence because it used to do some sequence of process. So it used to perform some sequence of process. Soon after starting up of your operating system, we have to initialize some various things that is required to manage your entire operating system. So you have your computer system, and in your computer system you have a power button. So normally what we will do, first we are going to switch on your computer system. So we are going to switch on. After then in your CPU central processing unit you have a power button. So we used to call that power button as an red big switch. We used to call it a red big switch, or we used to call it as an Vulcan nerve pinch, actually. VULCANNERVE, Vulcan nerve pinch, we used to call it as. So we are going to switch on that particular power button, and then we are going to start your operating system. While starting up of your operating system, first your computer system, your CPU will approach your hard disk drive, and from the hard disk drive you have what file system. In that particular file system you will have what, you will have the boot block. From the boot block we are going to start our operating system. So basically you have loaded your entire operating system in the file system. So in file system, one of the part which is going to be what, you have some various blocks. So one of the important block, this using this boot block, we are going to boot our operating system. Okay, so that's the thing about booting process or bootstrap sequence. So sequence in the sense it used to perform some various initializations related to booting. So soon after booting, it used to initialize some various components or else various data structures, and then various things that is required to manage your entire operating system. So to manage your entire operating system, and then to manage two set of processes, system level processes and user level processes, we need some various components. So using those components only we would be able to manage those system level processes and user level processes. So those initialization will be done by this bootstrap sequence. So that's why we're calling this a sequence. It used to perform some sequence of actions. Okay, so keep a note. So you have boot block. In boot block you have bootstrap sequence. Using this bootstrap sequence used to perform some various sequence of actions related to booting. Okay, um, and then the second part, you need init process. The init process which completely deals with user level processes. User level processes in the sense, those who are using that particular system, each and every individual user, it may be in user 1, user 2, user 3. So those users, whatever that they're going to do. Okay, for example, he may click on an icon, or he may open a particular application software, or he may type some word processing using keyboard. He used to type some word processing software. So all those things, whatever a user he is going to perform in computer system, automatically it will results in user level processes. So to manage those user level processes, we need this particular support, the init process. Okay, and then the so these are the basic things about system boot and init process. And the ultimate purpose, and the ultimate purpose is putting the operating system or placing your operating system into the machine memory. Okay, so placing your operating system into your machine memory. So basically, actually it is like in swapping process. actually, which is going to be like in swapping process, where from your secondary memory we are going to move that particular operating system into your main memory. Okay, that's why we used to call it as an placing operating system into machine memory. So this is going to be the ultimate purpose of system boot. Okay, or else we used to call it as an moving your system from an inactive state to an active state. So these are the two ultimate purposes. The first one, placing your operating system into machine memory, and second one, changing your system from an inactive state to an active state. Okay, and other than this, we have bootstrap procedures, and then we have init processes, and then various processes in Unix system like user level process, daemon process, and then kernel process. So all these things will be discussed in the presentation. Soumya, would you please open that PPT ma? Uh, System boot and in process. Open that PPT ma. Okay, so whatever so far I discussed with you, the same thing will be in the presentations. Okay, the purpose of giving some introductions and then getting into presentation is so initially you will have some idea. After then, while listening the presentation, you will get some clear idea. So that's going to be the purpose why I'm giving introduction and then getting into the presentation. So suppose straight away, suppose if I'm getting into the presentation and suppose I'm explaining some technical words over there, it seems to be an complex thing for you. So that's why first I'm giving introduction and then getting into presentation. Next slide, ma. Move to next slide, please. Okay, system boot and init process. So this is the title. So what we are going to do, we are going to initialize our system, and we are going to move our system from the inactive state to an active state. So to move from inactive state to an active state, we are using the system. And then here in the slide, we have mentioned things like what administrator, where administrator goes through bootstrap sequences, and then administrator is going to boot the system. So administrator here is nothing but you have some controls in your central processing unit. Those central processing unit which is going to act like administrator over here. Okay, you don't have any person or user to make your bootstrap sequence or that particular boot block to execute. Instead, in your central processing unit, you will have some control. That particular controller which will be acting like an administrator to fetch that particular bootstrap sequence from your file system. Okay, so normally the entire file system will be controlled by kernel. Here we have some important point. This boot block only actually initialize the kernel. Okay, so normally the entire operating system will be controlled by kernel. We have an changeover over here. The important thing here is, first, a controller, he is going to invoke the boot block, and in boot block the first part of your boot block, which is going to be kernel. So first we are going to initialize the kernel. That's going to be the first important utmost work that you're going to do in this booting up of your operating system. After initialization of that corresponding kernel, the kernel will control the remaining thing whatever that we have in operating system. So that's very important. So administrator boot the system, and what he's going to do, he's going to get the copy of operating system into machine memory. So this is the ultimate purpose, the two purpose that we have. The first one, which is about changing from inactive state to active state, that's going to be one of the first thing. And then the second thing, which is about moving a copy of your operating system into your machine memory. Make a note of these things. Actually we are going to take only copy of files, not an entire OS. Thus we are going to take what, a copy of OS only from your secondary memory to your primary memory. Actually we are going to move, we are going to do some swapping process over there. So this administrator or controller in your CPU will perform this actually. Okay, and then we are going to execute it. We are going to execute that particular operating system, and then you have a bootstrap program. So you have some bootstrap program. So this particular program, which is going to have some instructions. So using these instructions, whatever the other program that you have to execute, so that will get executed. So you have some bootstrap program. This bootstrap program will get executed, and using this program, other program will run in your operating system. And then we have some various bootstrap procedure. So this bootstrap procedure is very important. The purpose is the bootstrap procedure, which consists of some sequence of actions that it have to perform. That's about actually bootstrap procedure consists of some sequence, actually bootstrap sequences. So sequences, in the sense, it used to perform some various actions, whatever it have to perform related to booting process. The first thing that it used to perform is it used to read the boot block from the disk blocks and loads into memory. So first, the important thing, it used to read the boot block. Okay. So uh, so after performing those two actions, the first thing, the next important thing that we're going to do here is that we are going to read the boot block from your disk block. So from your file system, and from your disk blocks, we are going to read this boot block, and we are going to load it into memory. Okay. So soon after loading the boot block only, we are going to perform the entire remaining thing related to booting process. Okay. Move to next slide, ma. Move to next slide. And these are the various actions. So, I told you that we have some sequence of actions that to be performed during a booting process. So these are some various sequence of actions that is being performed during booting processes. So the sequence of actions are, the first one, which is about loading the kernel from the file system. Okay. So before loading the kernel from the file system, the first thing what we are going to do, the controller will invoke that particular boot block, and the boot block will be moved to the primary memory, and we are going to execute that boot block. The boot block, which consists of what, a boot program, or else we could call it as a bootstrap procedure, or else we could call it as a bootstrap sequence. Those bootstrap sequence, which used to have some set of subprograms with it to execute or to initialize some various things related to operating system. The first thing is what, the first thing is the program loads the kernel from the file system. This is going to be the first action done by your boot block or bootstrap sequence. So the program which loads the kernel from the file system, because the kernel, which is going to be an like a manager to manage the entire operating system. So first we have to wake up the kernel first. So first we are going to load the kernel from your file system. Okay. And what is the second action that we're going to do? We'll transfer control to the start address of the kernel and starts running. So first we are going to put the kernel into memory, and we have to execute that kernel. We have to switch on that kernel. So to switch on that kernel, we have to keep that particular pointer to the start part of the address of your kernel. So whatever the thing that we have to execute, normally we used to have a pointer, or we used to have an handler. So that particular handler or pointer will start that particular system. So here we have kernel system, and this particular kernel system, you will have some starting port address. So that particular pointer will first point out to the starting part of the kernel, and the remaining thing will get executed in your kernel. Okay. So the control will transfer to the start address of the kernel, and we're going to start running the kernel. And soon after running the kernel, you will have the entire control of your operating system. And the third thing what we're going to do, a kernel which is going to initialize its kernel data structure. So we have some various data structures. The kernel data structure, which is going to be a very important topic in unit 1. The unit 1 gets vast because of this particular data structures. So we have some various data structures in kernel. We have some data structures like U area, and then region table, and then process table entry. And so we have some various what file table and file descriptor table. So like that, we have some various data structures to manage your files and process. We have some various data structures. Okay. So those things, we used to call it as in kernel data structure. So to start your kernel data structure, um, we need this booting process. So soon after the execution of the kernel will initialize its data structure. So what is the data structure we need? So kernel will initialize its own data structure. And then the fourth action what it's going to perform, it's going to mount the entire file system. Mounting, in the sense, actually like a hanging of the entire file system. Keeping some places, and then we are going to mount in this, and actually we are going to hang the entire file system. In your entire file system, you will have all those existing files, whatever that you have created. So from the root node, and then various sub node, and then various files, and then various sub files, and the pathway between the root node and the sub files, all those things will be there in your file system. So that's about mounting the root file system. That's the fourth action. And the fifth action, which is going to be about system operating system running the process 0. So the fifth action, which is about swapper process. So it's going to start the swapper process. And then sixth one, which is about the process 0, which is going to fork using a fork algorithm. So it used to create a new process 1. So coming to point here, the process 0, which is going to which is going to invoke or which is going to create a new process, the new process which is going to be process 1. So the process 0 only, which is going to create what init process, the process 1. Okay, and what is the next seventh one? So process 1, we used to call it as what, init process, or else we used to call it as an user level process. And then where process 0, we used to call it as a kernel level process. So you have this question, so whether process 1 is an user level process or system level process, and then process 0 whether it is an system level process or user level process. Okay, so like that you will have a question. So keep in mind, process 0 and process 1, basically both are what, which is going to be in system level process, but process 0 we used to consider it as system level process, or we used to call it as a kernel level process. At process 1, which is what, which is though it's going to be works like a system level, which is going to support the entire actions of users, so we used to call it as a user level process. Okay, and then what is the eighth action we are going to do? The process 1 calls or execute other program. So whatever the other program it have to start related to users, it will start. And then what, so this process 1 is otherwise called as an init process, which is going to be responsible for initialization of new processes. So these are some various actions done by your bootstrap procedure or bootstrap sequence. Okay. Thank you, students. Thank you for listening patiently. So already it's time up. So with this, I would like to stop the session. So thank you.